So this is the work solutions for the calculator part of your compo. I will upload a second video that has what I'm doing on the calculator using my mini iPad, so you can see exactly how it's done. So using your calculator in any way you wish, determine the equation of the tangent of g of x where x equals minus 2. So you can type into the calculator tangent line and all of that stuff, but I'm going to do it by hand. I'm going to show it up the calculator secondly. So first of all, I'm going to differentiate the g of x. I'm going to substitute minus 2 into it. So this equals to 14 times negative 2 is minus 28. Minus 28 add 3 is minus 25. So that gives you the gradient at that point. So we do y is equal to mx plus c, but we need to have the y coordinate, so let's do the y coordinate. So g of minus 2 is equal to 7 lots of minus 2 all squared plus 3 lots of minus 2, which is equal to, just get the calculator to do this all for me. So we know that y is 20, m is minus 25, x is minus 2 plus c. So 20 is equal to 50 plus c. So c is equal to minus 25. So we get y is equal to minus 25x. That's right. Sorry, my mistake. Minus 25x, and c is minus 25 as well. What am I talking about? What am I talking about? Of course c is not minus 25, c is minus 30. I might have made a mistake. I could drop by check that. Okay, but the calculator had done that for you anyway. Part B. Given that f2 equals 511, show that k equals 4, you must show your important working steps. So I know that f of x is equal to the rational function kx minus 3 over 3x plus 5. Now, you've had quite a few of these questions. This one's quite similar to this in the class. Now, we know that when x is 2, f of x is equal to 5 over 11. Am I given any other information on it? Show that k equals 4. Okay, so I'll leave k to be 4 for now. So we've got 5 over 11 is equal to k, which we don't know, but we know that x is 2, minus 3. So 5 over 11 is equal to 2k minus 3. 3 times 2 is 6. 6 plus 5 is 11. Okay, now we can use the calculator to solve this, but I'm going to multiply it by 11 on both sides. When I times it by 11 on both sides, the 11s are going to cancel. So I'm left with 5 is equal to 2k minus 3. I'm going to add 3 to both sides, so get 8 is equal to 2k, divide by 2, k equals to 4 QED. Add a few marks to it, so that first one was worth 2, and this part B was worth 3. Part C. Determine the domain, range, and therefore the horizontal and vertical asymptotes of f(x) show key working steps. So we know f of x is now going to be 4x minus 3 over 3x plus 5. So the domain, x can take all real values, but it cannot be when the denominator is, the denominator is equal to 0. So therefore, x cannot be the same as minus 5 over 3. We can't let that be equal to, can never equal 0, so that's why x minus 5/3. You could have done 3x plus 5 is equal to 0 and solve that and get x equals minus 4. That's where I get that from. Therefore, now that gives you the vertical asymptote, x is equal to minus 5. I'm pretty sure I asked for the vertical asymptote. Determine the domain range. Yeah, okay. Now, the range is y can take all values but y cannot equal 4 over 3. I get the 4 from here, I get the 3 from there. And therefore the range gives me the horizontal asymptote, which therefore the horizontal asymptote is y is equal to 4 over 3. And that, I think, is everything I need. Determine the domain, range, and therefore horizontal. Okay, show key working steps. That's 4 marks. Hopefully you found that to be 4 very easy marks. Next bit, D. Sketch f(x), ensure you show all key coordinate points. Okay, you can use this on the calculator. Now, does it say? Okay, I'm going to do a bit more in addition. So we have, that's equal to 4x minus, oops, I'm making a slight mistake here. Get this right, over 3x plus 5. So what this is doing is finding when x is equal to 0, which is equal to minus 3 over 5. So we have x is 0, y-axis is minus 3 over 5. Let's multiply by 3x plus 5, so we get 4x minus 3 is equal to 0. Solve for that. X is equal to 3 over 4. I'm going to show you how to do all this on the calculator shortly. 3 over 4, comma 0. So using these points, I've got 0 minus 3/5, let's call that there, minus 3 over 5, and then 3/4, 0, something like this. We know the asymptote, the horizontal asymptote is 4 over 3. Does something like, this is 4 over 3, and the vertical asymptote is at minus 5. Something like this. So when I put in my curve, oh, some lovely colours there, it goes something like that. And that's, I think, oh, don't forget my, let's label the axis y, x, and we're looking at 4 marks. So we're on to E. Determine all the points of intersection with f(x). Okay, so E. Oops, I don't want that in red, I want that in blue. So for f of x is equal to 4x minus 3 over 3x plus 5. Just make sure I get that absolutely right, yeah. And g of x is equal to 7x squared. Oops, I've forgotten it. 7x squared plus 3x minus 2. Plus 3x minus 2. I've got to know all the coordinate points of intersection. So what I have to do is I have to solve them simultaneously. I will let them equal each other. So I'm going to start by saying let f of x equal g of x. So I've got 4x minus 3 over 3x plus 5 is equal to 7x squared plus 3x minus 2. And I'm going to solve for that. Now I'm going to use the calculator to solve for that. So menu, algebra, which is 3, solve system equation, which is 7, and then 1. I'm going to put everything in that I know. So I'm going to start by putting in 4x minus 3 over 3x plus 5, and that's equal to y. And then on the bottom I'm going to put 7x squared plus 3x minus 2 equals y, and push, and it's the 3 decimal places. So we have x is equal to minus 1.873, y is equal to 16.94, 1 to 3 dp, or x is equal to minus 0.547, and y is equal to minus 0.284, again to 3 dp. Did it ask for the coordinate points? I think it did. Yeah. So what we have is minus 1.873, 16.941, minus 0.547, comma, and that was 4 points, with the calculator doing the vast majority of the work. Notice this here, if I was to solve that, would only give x values, and you'd have to sub back into for y values. Oh, sorry, 3 sig figs. I misread 3 sig figs. So if it's 3 sig figs, I'm just going to do a bit of deleting. That goes to 5. Oh, wait a minute, no it doesn't. That was already rounded to 3 sig figs. Okay, and that's to 3SF. The last one of this question, F, on the graph you sketched in part E, also sketch g of x, and only by considering the function. Okay, so I need to sketch g of x. So I'll show you that. So on the calculator, so I'm just putting this into the calculator to just do a quick sketch of it. It does. It's doing something like this. So I'm considering only this part here. If you plot it perfectly, it will show you. I'm going to leave F for the calc. I'm going to upload this in stages, okay?